Today we're looking at charging by induction. So previously we've looked at charging by conduction. This is going to be something similar. It's about charging an object. And it's one of the three types that we're going to be looking at. So this is going to be the second type. So charging by induction, it's possible to charge an object without coming into contact with it. And you can, if you want, you can reference page 487 in the textbook. But essentially, we've looked at something similar to charging by induction before. When a neutral object comes close but does not touch a charged object, the electrons in the neutral object move. So this was induced charge separation that we've touched on previously. And we looked at the example where the negative balloon moves towards the neutral wall. The negative charges in the balloon repel the negative charges in the wall. We're not charging the wall. We are creating an attraction between the now slightly positive surface and the negative balloon, but we're not changing the charge in the wall because the number of electrons and the number of positive charges are still the same. So we're not changing anything, we're not charging anything, but we are kind of separating a few of the charges to create an attraction. If we do want to charge an object by not touching it, but by coming close, or charging by induction, an object can be permanently charged by induction by grounding the object. And we have previously talked about grounding. That's where we remove excess electrons. So the steps in order to do that, we want to first bring a negative rod close to an object. From there, all electrons will flow to the opposite side of the object away from the rod, creating a charge separation, or this was the induced charge separation that we talked about previously. Once that occurs, the electrons will escape down the ground, making the charge permanent. So the electrons will be removed from the object by moving down the ground, and that will make the charge permanent. So here we can see we have a negative rod and a neutral ball. Right? The negative rod because we have more negative charges or more electrons, and then in our ball it's neutral because we have equal number of positive and negative charges. So the first step is to induce the charge. So we've brought our two objects close together. The negative charges in the negative rod have pushed the electrons to the opposite side of our neutral object. Step 2, we're going to attach a ground, and here the electrons or the excess electrons are going to be transferred down the ground. So they're going to be pushed out of the object by the negative rod, and they're going to be pushed down the ground. So they have now been removed from the object. Now to remove them completely, we have removed the ground, so that takes the electrons with it. And now we've ended up with a negatively charged rod and a positively charged ball. So again, charging by induction, one thing you want to note is that for the charge to be permanent, the ground has to be removed before the charged object is removed. So if we had left the ground on and then moved the object or that negative rod away, the electrons would have moved from the ground back into the object, kind of reversing what the ground has done. And charging by induction will always result in two objects with opposite charges. So the negative charged rod would push electrons out, and that would create a positively charged object. So we're going to have two opposite charges. This is different from conduction, where conduction, the two objects will have the same charge and the same type. So for practice, you can try to create your own charging by induction diagram for your notes, just again to get a better idea and just to kind of repeat or memorize or go over again the steps to charge by induction.